I am back with another video from IIT JEE in 1999, and this is a beautiful problem from the topic Harmonic Series. Okay, this question was rumored to be very hard, and if you see some special case and if you just add them up like you always do probably when you see that we have to do something up to nth term and you just want to take a special case and you just want to reduce the problem to the special case and want to see a pattern, but this problem is a bit hard to do like that. Even though add the harmonic series to a few term is a humongous task, right? And then you can see this 2 to the power n, and then you probably will have to add up to 2 terms or 4 terms or something like that, right? Then only it makes some sort of sense. So reducing it to special case, it's probably not feasible, and as it's a multiple choice answer, I forgot to tell that, so let me just write it here. Okay, multiple correct type. So this would be multiple correct type. Okay, so but I am going to tell you that this problem is very easy if you just look carefully what this problem is trying to say. At least a part of it is very easy. The second part is a bit difficult. Okay, so this problem is inspired from the harmonic series that you mostly get in elementary real analysis, and in the proof when they proved that the sum of harmonic series up to infinity is not bounded, it goes to infinity as well. So in that proof, whatever the trick that you use in this paper, basically they expected you to use this. So unless you know this trick, this problem looks humongous or unsurmountable, but if you know this special trick, then it becomes really easy. So let me show it to you for those who have not yet reached up to elementary real analysis or something equivalent. Okay, first of all, let's try to find out this a100 term, right? But if you have read this really good book by George Polya, it's called How to Solve It. So in there it's written how you can approach any problem. Okay, first of all, you always have to break the problem down to special cases or smaller manageable version, and then you need to try out a few things. Then if that does not work, then there are other techniques like generalization, drawing a picture whenever it is possible. But first of all, let's go with the basic most thing, right? So if it's saying that we need to go up to nth term, let's try to go up to 3 terms, maybe like a of 3, right? That kind of makes sense to me. So let's try. Okay, a3. It would be 1 second term, right? Third term. Can you tell me where till which term should I write? See, you just need to put 3 in place of n, right? 2 to the power 3 minus 1. This would be 7, right? So that's pretty easy. 5 plus 1 by 6 plus 1 by 7, right? And now the trick that I was telling you about is that you can pretty much see here what I am doing here. Okay, this is 1 by 2 plus 1 by 2. So 1 by 2 is greater than 1 by 3, right? So I am just replacing 1 by 3 with 1 by 2. Okay, so that's why we got this greater than equal sign. If we want, we can use strict inequality, because in this case the inequality is pretty strict, but I am trying to make it as general as possible, because if you look at only first term, then a1 will be 1 here, right? And so the inequality won't follow it. It will just be equality, right, when we go up to the first term, because we did not change anything in the first term. Okay, so that's why this inequality, to keep it general. So a1 will be equal to just 1, but if you see like a2 and 3, then this inequality will become strict. Okay, so yeah, let's see. 1 by 4, it will be 1 by 4 only, and 1 by 4 replacing 1 by 5, we are replacing it with 1 by 4, something greater. 1 by 6, again 1 by 4, and this would be replaced with 1 by 4. See, if you take this 4, this 2, and this 1, see, everything sums up to 1, right? And you can pretty much see that this is less than equal to 3. And by the same logic, if you do up to nth term also, it's very easy to see that an is less than equal to n, right? So this you should not even bother doing, because you can see this clear pattern. So this obviously generalizes. So this 1 is correct, right? So first thing what we got is that 1 is correct. Let me just write it down. 1 is correct. Okay, 100 is less than 100. Now let me do the second part. Second part is a bit tricky. Okay, if you did not go through elementary real analysis, or probably you never saw this trick before, then it becomes a bit harder. But if you have carefully looked at this first part, then you will probably figure out. Again, we are taking the 3 case. Okay, so 1 by 2 plus 1 by 3 plus 1 by 4 . So what we do here is that we leave the first 2 terms, okay, and this we make 1 by 4, so something lesser than this. So what will happen here is that we will get the reverse inequality. Okay, so 1 by 4 plus 1 by 4 plus 1 by 8 plus 1 by 8 plus 1 by 8. But if you look carefully here, this is summing up to half. Ignore this term, okay, for the time being. This is summing up to half. Here if we sum this 3 1 by 8, then we do not get half. We need another 1 by 8, right? Because if everything was half, it would be easier to find a pattern, right? We can just easily sum them up. So what we are going to do is that in the next line, we are going to shift this 1 here and write 1 by 8 here, and then remove rest 7 8. So obviously 1 is greater than 1 by 8. So if you can easily see this inequality holds. Okay, this is now strict. This strict inequality, right, for all the cases. Just a second. Yeah. So 1 by 2, 1 by 4 plus 1 by 4, and 4 1 by 8, right? This 1 plus 1 by 8 and plus 1 by 8. Okay, now let me just mark them by the same color, this 1 by 8 and this 1, okay, where this 1 by 8 came from. So a part of 1 came here and the rays just went out. That's why we got this strict inequality. Okay, so now the summing up this part is really easy. So if you think about it, you take common. Okay, just a second. So 1 by 2 will come out. Okay, I think I picked the wrong color. I picked the right one. Yeah. 1 by 2 will come out, and we get 1 plus 1 plus 1. So it is greater than 3 by 2. So you can pretty easily see that the pattern would be that a n is greater than n by 2, right? In place of n, if you put like 2n, then it's apparent that a 2n is greater than n, right? Now if you see, if you put 200, then it's pretty evident now, right? 200 is greater than 100, right? So we found that option number 3 is also correct. Let me just write it down. Option number 3 is also correct. So we solved the problem. Okay, I hope it's clear now. Yeah, so that's it for today. Hope you liked the video. If you did like the video, please press the like button, and I would really appreciate if you would subscribe to my channel so that you get a notification whenever I upload a new video. And see you later. Take care. Bye bye.